Okay, so in the previous class we were seeing about the belt drives. Okay, and yes, so let's continue with that today. Okay, so what we had seen is that there are two types of belt drives. One is an open belt drive, the other one is a cross belt drive. Okay, right. So in this, uh, as as it is shown in the picture over there, there's one pulley, okay, which can be of any diameter, either larger or smaller, okay, and mounted on one particular shaft. And similarly, there is another shaft over a particular distance. Okay, this is the distance between the two shafts, and here we have another pulley mounted onto the second shaft. So onto these two pulleys, the belt is going to be mounted in this particular way. Okay, where now if one of the shaft is connected to a uh, motor or a crankshaft of an engine. So before going to that, so this is, let us take that this is the front view of this, and this particular thing is the top view of the belt drive, where this is shaft number 1. Okay, and this is the pulley D1 or bigger diameter pulley, and here we have another shaft. Okay, and this is the smaller pulley that is mounted onto the second shaft, and this is the belt connecting the two pulleys. So if this particular shaft is going to rotate, okay, right, and then what is going to happen is that it is going to pull this part of the belt, so it is going to be under expansion, and this particular region will be having a higher tension, therefore it is called as tight side. Okay, and this belt is going to slide over the surface of the pulley, and there is contact between the pulley and the belt in this particular region, so there is also friction also. And after this particular region, the belt is released from the pulley, so it is no more going to be in expansion, so there is going to be a slight sagging of the belt, which is called as the slack side of the belt. And what is going to happen if this particular pulley is going to rotate in clockwise direction, due to it's connected as open belt drive, the the other pulley will also rotate in the same direction. Okay, will also rotate the same direction in open belt drive, right? Okay, and the most important terminology over here is that if this particular shaft is going to be the one for which the rotational motion is going to be is being given or produced from here, that is by connecting it to a generator or a crankshaft of an IC engine, then this particular pulley is going to be, this end is going to be called as the driver end, because this is the one that is going to drive the pulley, okay, this shaft. So it is called as the driver end, and the one that is going to rotate because of the driving motion by the other pulley. Okay, so therefore the one that is going to receive this rotational moment, okay, is called as the driven end. Okay, so there will always be a driver and a driven end, nothing but the pulley that is going to give the rotational moment and the pulley that is going to receive the rotational moment. Okay, right, so driver end and driven end. Okay, right. And yes, the next thing is that when we have say for example uh, what we actually need power transmission is not only for rotational moment but also for uh, to increase the speed of rotation or to reduce the speed of rotation. So it's not only to just to transfer the RPM, that is rotations, from one shaft to another shaft, but also to change the speed of rotation. Okay, right? So for both, for this purpose also we need. So so if at all, if you want to increase the speed onto the driven end, so then what should happen is that onto the driving end, the pulley should be of a larger diameter, D1. At the driven end, the pulley should have a smaller diameter, D2. So now what will happen if this pulley, now let us assume that, okay, just a second. Okay, now coming back to this. So if we have, now let's assume that this driver end, the pulley on the driver end has got a diameter D1. Now let us say it has got 1 unit, and the pulley onto the other end, the driven pulley, has got a D2 diameter, nothing but half a unit. So that means this is twice as big as the driven pulley, right? So if this is going to make one rotation, then for this one rotation, this pulley, since its diameter is smaller, okay, this will go for two rotations because the diameter is different on both the ends. Here it is going to be, it is 1 unit, here it is going to be half a unit. So that means if this is going to make 360 degrees of rotation, okay, so before that, since it is 1 and 0.5 units, okay, so by the time it makes 180 degrees of rotation, this pulley would have gone for one full complete rotation of 360 degrees because its diameter is smaller. Okay, so thereby what is going to happen is that, so if this pulley is going to make one rotation, then since this diameter of this other pulley is smaller, then this is going to make more than one rotations. Okay, so it all depends upon the diameter D1 and D2 values. Okay, whether it's going to make higher number of rotations or lesser number of rotations. Now if you want to have lesser number of rotations, we want the speed reduction. Okay, now then in that case what we can do is that we can have a smaller pulley over here and a larger pulley at the driven end. So by the time it makes one complete rotation, this wouldn't have yet made one complete rotation. It will have made only less than one number of rotations because the diameter is different. Now the other case is that if we have at both the ends same diameter of pulley, okay, then what is going to happen, since the diameter is same, if this is going to turn for one rotation, this is also going to rotate for one rotation, right? Okay, so the speed is going to be the same, right? So based on this, whether we want to increase the speed or to decrease the speed, this power transmission is going to be helpful. So by one of the means is belt drive. Okay, right, so this is all about the open belt drive. Now let us see about the next type of belt drive, that is the cross belt drive. So in a cross belt drive, yes, again here we have the front view, here we have the top view of the diagram. Okay, and we have one particular shaft mounted with a pulley D1, let us assume, and at a particular distance, okay, there is another shaft that is over here in the top view, okay, having a smaller pulley D2. Okay, okay, now if you look at this, the belt is no more connected in a straight manner like this. It has been crossed like an X. Okay, right? So this is why it is called as cross belt drive. Okay, so what is happening over here now, if you look at this carefully, uh, now if this shaft is going to be the driver end, okay, and if this pulley is going to be rotated, okay, now since the belt is connected in a cross manner like an X, okay, so what is going to happen is that this belt is going to move in this fashion. It's going to start rotating like this, right, and this continues. Okay, right, so what is going to happen, the first thing is that the if the driver pulley is going to rotate in one particular direction, the driven pulley, since it is a cross belt drive, it is going to rotate in the opposite belt, sorry, in the opposite direction. So this is the one of the differences in the between the cross belt drive and open belt drive. Okay, right. So the next thing that comes into picture is that, yes, here also we are going to have tight side and slack side. So if this pulley, the driver pulley, is going to rotate in clockwise direction, so this particular region of the belt is going to be pulled or extended. Okay, so thereby it is going to have more number of tension. It is called as the tight side. But after this, it is going to slide over this pulley, and here the pulley is going to be, sorry, the belt is going to be released. So there is not much tension, so there will be a slight slack in this particular region, therefore it is called as the slack side, and it will have a lesser tension denoted by T2. Okay, right? So this is the next point. Then the next thing is that the uh, next thing that we should carefully observe over here is that one important terminology is called as the arc of contact. Okay, arc of contact. So what is this arc of contact? Now, if we just take up only one particular pulley over here, in a cross belt drive, the belt comes in contact with the pulley at this particular region and the belt leaves the contact with the pulley over here. So for such a large angle, the belt is in contact with the pulley surface. Okay, only for this particular region the belt is not in contact with the pulley, right? Similarly, if you look over here also, it is the same case since it is a cross belt drive. So the pulley comes in contact over here and leaves it over here. So for this particular region, the belt is in contact with the pulley, right? So this is called as what is the arc of contact, for what is the angle of this where the belt is in contact with the pulley, for what is that angle is very important for the derivation. So it is called as arc of contact. Now coming back to this, let us see where compare with the open belt drive. Now in an open belt drive, okay, in an open belt drive, so just look here. The belt is in contact with the pulley only for this much, okay, right, which is comparatively a lesser angle, okay, comparatively a lesser arc of contact. Okay, it's the similarly over here also, it will be usually over here. Since the diagram is small, you can't see here, it will be only for so much, the arc of contact. Okay, but whereas if I take up, I'll just redraw it here only. If I just draw and for a cross belt drive, so if it is a cross belt drive, it is starting to be in contact from here. And similarly, if you look here, the belt is going to be in contact with the pulley from here. So such a large angle. Okay, right? This is also very important. Okay, this is the difference, another difference between open belt drive and cross belt drive. In open belt drive, the arc of contact is lesser, and in cross belt drive, the arc of contact is higher. Okay, right. Okay, right. Okay, so yes. Okay, so usually we would have seen this, generally use this step cone, step pulley drive or a cone pulley drive. So what is going to happen where we want to change the speed? Okay, we want to change the speed whenever it is required. So what they will do, so one of them is the main shaft or the driving shaft on which a cone of stepped manner will be formed like this. So it will be like this. So if you just look at it, it will have a larger diameter in a stepwise manner. So here we have three steps where we can put the belt over here, smaller diameter. We can put the same belt over here, a little bit larger diameter. We can put the belt on this particular bigger diameter also. So it looks like a cone or in the form of steps. So this is one kind of uh, pulley arrangement that has been done. So similarly onto the driver end also, we will have the reverse order of this. So if we take up from here, starting from the left, we have first a smaller diameter, then medium, and then a larger diameter. So if you look at the driver end, so it will be the reverse. So wherever we have the higher diameter, in line with that, we'll have the smallest diameter, and then the next bigger diameter, and then finally here onto the driving shaft, we have the smallest diameter, So on the driving shaft, we'll have the highest diameter. Okay. So why we need this is that to vary the speed of rotation. Okay. To vary the RPM. Now, if I fix the belt over here, so on the driving shaft, we have the larger diameter, and on the driven shaft, we have the smaller diameter. So D1 is higher. Okay. D2 is smaller. So what is going to happen, since this is going to cause the rotation? So if this goes for one rotation, since on the driven shaft, the diameter is smaller, this is going to make more number of rotations. So we are going to increase the speed. If this is going to make one rotation, then this will make more than one rotation since the diameter is smaller than D1. Now when we put the same belt, okay, length of the belt is going to be same. When we put the same belt over here, okay, when you're going to place the same belt over here, okay, let us assume both the diameters are equal. Okay, let us assume both the diameters are of the same unit, same number. Okay, so it is only going, if this is going to cause one rotation, then onto the driven shaft also it is going to cause the same number of rotations only. There's no change. Okay, now let us go to the third one. So here we have a smallest pulley onto the driving shaft, and here onto the driven shaft we have the bigger diameter. So if we place the belt over here, okay, so D1 is smaller, D2 is bigger or larger in diameter. So if this is going to make one rotation, then this would have made only less than one rotation, maybe half a rotation or something like that. Depends upon the diameter. Okay, right? So because of this, whenever we want to vary the speed, only by replacing the belt onto the required pulley, we can vary the speed. Okay, right? So that is why the step cone pulley drive arrangement is required. Okay, yes. Okay, so yes, we'll go to the next one. Okay. Right, so yes, we will see the derivations in the later on stage. So let us first go to the advantages and disadvantages of flat belt drive. So advantages of flat belt drive, what is that? Is that first of all, these belt drives are flexible, okay, simple in construction and smoother in operation. They don't make too much of noise and all those things. Okay, very smooth operation, simple construction. Okay, all we required is a pulley and a belt. Okay, so yes, it is efficient at high speeds. Okay, it is efficient at high speeds and protects against overload. So at overloads also, the belt will not get cut so easily, so it can bear that load at high speeds, okay, but not at lower speeds because the belt will be at a higher tension. So there's every possibility that the belt will expand and lose its elasticity, and finally it will get cut. Okay, right. The running and maintenance cost is also low when compared to other types of uh, power transmission systems. Okay, so this is one of the advantage of belt drives. Okay, and belt drives usually have a longer life. Okay, and easy to work. So any kind of adjustments that has to be done, yes, it can be done. Right. So disadvantages is that there is loss of power due to slip. So what is this slip? Is that nothing but we have the belt that is over this pulley. So if it is not over this, uh, so we have this belt over here like this. Okay, and this is the shaft. Sorry, the pulley and the shaft is, sorry, the pulley is going to rotate in this particular direction. If the belt is not to the required tension, if the belt is too loose, so even though this pulley is going to rotate, the driving shaft is going to rotate at the driven end, this belt will not at all move, okay, because it is too loose, so it will just slip over here in this point, in the path of contact, in this area of contact, it will just slip because there is not enough tension. Okay, if there is too much of tension, then the belt will cut. If there is less tension, that is the belt is too big, okay, and the belt is too loose, then it is just only going to slip. So this we would have experienced sometimes whenever we have when we ride a cycle. So sometimes when the chain is loose and we try to pedal it fast, the chain will just come out of the sprocket because the chain has become loose and it will just slip over its sprocket. The same thing will happen over here also. So there is slip that will come into picture over a period of time because of creep, that is the expansion of the belt, and will lead to power loss because it is only going to slip, okay, and thereby lead to lower efficiency. The next one is that uh, not preferred for short distances because it is capable for longer distances, because for shorter distances, uh, because of this load power transmission and effective loading conditions, okay, uh, this it is not preferred for shorter distances. Rather than this, for shorter distances, V belts are preferred. We'll see that. Okay, right. So uh, the next thing is that for an open belt drive or a cross belt drive, okay, whenever we go to a floor mill, we may see that over this pulley, if we have this belt, okay, and there will be joints made up like this wherever the belt is being cut, okay, and the more the number of joints on this belt, okay, okay, this will lead to power loss because at this particular portion, okay, it is like this, the belt is not flat, so there is no contact over the pulley over here, so there will be a slip over here, okay, so thereby there is more power loss, okay, so number of joints should be less, otherwise there is going to be less power transmission, right? So these are some of the advantages and disadvantages of flat belt drive. Okay, so yes, so we will see the next one, and we'll go to V belt drives. In V belt drives, it is very compact. So as we have seen in a V belt drive, the pulley will be like this. Okay, and the belt will also be in a trapezium shape, V shape only. Okay, so this will be the portion of the belt, right? Okay, so it has got compactness and it is generally used for small distances. V belts are used only for transmission power over smaller distances, but not for larger distances, because for larger distances, there is more power loss in V belts. They are not capable of it. Okay, and yes, so this is a positive drive, that is the slip between the belt and the pulley is negligible because there is more amount of surface contact on all the three sides of the belt. Okay, but that is not the case in the open belt drive. It has got belt contact between the belt and the surface, and the pulley surface is only on one side. Okay, right. Okay, and yes, V belts will not have any joints, so it will be one continuous endless belt. Okay, so thereby the power transmission is smooth and efficiency is also high. Life of this V belt is only for up to 3 to 5 years. After this, because of continuous expansion and contraction, okay, they will lose its elasticity and its uh, length of the belt will change. So thereby it has to be changed over after 3 to 5 years. Okay, generally. Right. So it is easily installed and removed. So there is not much. So since it's an endless belt, it has to be only mounted onto the pulley, right? So there is no kind of any kind of adjustment and restricting, maintaining the particular tension and all those things. And yes, so operation of a V belt is very quiet. Okay, yes, and belts have the ability to cushion, have the shock resistant system, because once from stationary position, uh, once the system has been started, there's a sudden movement of the pulley which will create a sudden expansion of the belt, pulling it suddenly. Okay, so thereby this will lead to some kind of expansion on the tight side, okay, creating a shock onto the overall belt. Okay, so this has got much more better capability because it is made up of balata, then other materials, and it will also be reinforced with wires made up of steel also, so that can resist the shock. So but that is not the possibility in open belt race. Okay, great. Okay, yeah. Mm, yeah, so these are some of the advantages of belt drive. sorry, of a V belt drive. Okay, right. So yes, we'll stop here for today.